So, more practice with our solving irrational expression equations. Reminder, probably the easiest way to tackle these is going to be how we've been working with them. I did make mention yesterday of a separate video that I made if building fractions isn't your forte, but there's some dangers with that, which would be when you're not solving, it wasn't working. It doesn't work. So we're going to kind of keep this available as we're doing some of these. So when we're solving the equation, we'll talk about the extraneous solutions when we get done. Big word, simpler concept. So when I'm trying to find my common denominator, again, I'm not paying any attention to the numerator at all. Not at the start. So when I'm working down my checklist, okay, coefficient, yep, I got a 2 here. I don't have any other numbers, so I don't have to think about that. We'll get to that and some others. Okay, single variables, again, where there's no plus or minus. Okay, I don't see any pluses or minuses down here in the denominator, so they're all single variables. How do I know what to use? Use the largest one. The largest variable? No, Harty, the largest exponent. Okay, so the largest exponent I see is squared. So 2n squared. And then if there would have been pluses and minuses, I'd have taken those parentheses and put that in here. But that's not here. So, once I've got those, that looks to be my new common denominator. And again, that's why we do this. Because when you're adding or subtracting, you've got to have a common denominator to get there. And we'll always put back what we started with in there. So once that's done, now we go into builder mode. And we chatted a little bit yesterday about a couple of ways you can do this. One is kind of our old-fashioned, okay, I'm going from old to new. If you can visualize that, some of you may look and say, well, hey, I've got the n squared part. I need the 2, so that's what I'm going to put up there. Others of you that are more visual this way may want to look and say, I started with n squared. I got to multiply that by something to get to 2n squared. Well, if I've already got the n squared times 2 would be 2n squared, and that's how you figure it out. So you've got both of those options on each of these. And so we'll kind of go more visual on this one. So I look here, well, I see I need the 2, but I also notice this time I've only got one n. I need it to get up to 2, so I would need another one. 1 plus 1 gets me 2, so 2n. And then my last one, same thing. I start with 2n. I want to get to 2n squared. I got the 2. I got 1n, but I need 2, so I need one more. So seriously, if the side thing and just being able to do the same thing and visually see what you're multiplying to get across works for you, that's the route I would go as far as those go. Thank you. So that's what we're going to take a peek at. So once we have that done, we can get this out of the way. Our denominator has done its job. Now again, the only time I get to do this step, bless you, is when it's an equation, when there's an equals. That is the only time I get to say peace out to our denominator. And what's going to be left is whatever I have in the numerator. 1 times 2 is 2. 1 times 2n is 2n. 5 times n is 5n. And I'm just going to solve the equation that's left. So, well, I got to get all my n's together. So I'm going to choose to just move them all to the right side here. And then I divide by 3. And I get a fraction. We'll leave it as such. But then we get to have a little chat about that second sentence. Remember to check for extraneous solutions. Now, an extraneous solution just means it's a number that if I plug it into the problem, causes a denominator to be 0. It causes my equation to be undefined. So we chatted a little bit yesterday about this just means make sure the denominator doesn't equal 0. There could be some other situations that come up, but that's really the only basic one we're going to be dealing with on these. So, a lot of times I can just eyeball it. I can look and go, you know, let's see here. 2/3 squared. Okay, that didn't equal 0. That's just 2/3. That's not going to equal 0. 2 times 2/3. That didn't equal 0. Okay, I'm good. The only time that would cause a problem, like let's say we'd have gotten an end value of 0. Well, 2 times 0 is 0. That's going to be a problem. So I'd have to look at that and work that out. So that's one thing we can deal with. Let's see. I got some others we want to play with here that are a little bit different as we go. Let's say we go down to number 6. Yes, number 6. So when we get down here, again, first thing, everything needs to be a fraction. So that 1, I'm going to put it over 1. And once I do that, like we did before, for the moment, we're going to ignore what's going on in the numerator. Now this time my LCD is pretty easy to come up with. Okay, I got that 1 there. I could include it. I really don't need to, though. Single variable of x, no parentheses. And my biggest thing on this one and why I chose this one, you're like, why did you even pick this one? Is because I wanted to make sure whenever we don't have a fraction that we remember we need to make it 1. And whatever was up there to begin with is still there. It also gave us a reminder that whenever we see pluses or minuses anywhere in these problems, if there aren't parentheses around them to begin with, we need to put them there. So when I start to build here, and again, if you're visual, having a piece of scratch paper, there is nothing wrong with that. I got 1 to start with. I got to times it by something to get to x. Well, that's pretty straightforward, x. So I'll get that in there. The next one, I start with x. And if I'm going to end with x, if it's the same thing, okay, I can do nothing or I can use a 1. That'd be okay as well. And then my last one. Start with x. Want to finish with x. That'd just be 1. Now, if the whole thing with the arrows and stuff messes with you, you don't need the arrows. You're just going to have to follow and kind of keep track of that here to the side. But once I get those numerators built, denominator can go away again, only in equations. And I simplify the stuff that's up in the numerator. Ooh, here's my other reason for picking this one. See this minus that's here? That minus, that negative. So this is like a -1 that's distributing all the way through. Not just to the 2x, but also to the -8. So -2x and +8. Because if I forget the parentheses, I'm going to have -8. That's going to mess me up, and I'm going to get this wrong. So I look. If I have like terms that are on the same side of the equals, I need to get those together. And now I go back to my Algebra 1 roots. Now again, I got to get the x's to the same side. They're not on the same side of the equals, so I got to do an opposite to move them. I always like to find the side that just has x and move them there if I can. Remember, there's a 1 in front here. And normally, before I would circle Again, I want to check and make sure that it's not extraneous, but this time that's pretty simple because you're just plugging the number in here. There's nothing else to do to it. Is it going to make it 0? No. Plugging 3 in for x is definitely not going to make it 0. So that one works out just fine. But again, I always need to take a moment to check. Again, just take your time. Keep getting that practice at building your numerators. Man, you get that down, it knocks out all the adding and subtracting stuff from before, and it gets you on this too, so it's kind of like 2 for the price of 1. Now, as we head to the back, okay, we got a couple more back here I want to take a peek at with you. Again, if you see pluses and minuses anywhere, immediately start parenthesizing. I don't even know if that's a word, but things. And here's our additional bonus on this one. If there's anything in the denominator that's factorable, we need to factor it. So I look at my first one, x plus 1. Okay, no. I look at my second one, x squared plus x. Okay? Do they have something in common? Yes. They both have an x. So I pull that out. X times x is x squared. X times 1 is x. And I notice this next set of parentheses is the exact same thing. So I'm going to do that. You're like, why is that so important? Why couldn't I just go down my LCD list and I wouldn't have had coefficients or single variables? Why couldn't I just use this and this? I could, but I'm going to have to do a lot more simplifying later. There's a lot more places to make an error. By actually simplifying this now, when I go to build my LCD, okay, I do not see coefficients sitting out in front, but I do see single variables. They're not in the parentheses anymore. That's part of my LCD. I do see parentheses, x plus 1, but that's the biggest exponent I see at an x plus 1. Don't write to the third, okay? Just the biggest exponent you see. So once I have that, that's going to be my new denominator, and I'm just going to uncover this so I can actually see what I'm doing. Put all your stuff that was up there to begin with. And now that we've got a common denominator, again, we're going to go into builder mode. Scratch paper if we need it, A-OK. Old to new. Now, we've talked before, there's a couple ways I can do this too. Normally, when I have parentheses in play, I like to just check them off and say, okay, I got this set of parentheses. I didn't check off the x, that's what I need. Could I still do my little side work way? Sure, I could look and say, yep, I got this part. I need that part. It works. Okay, you've got to find what works for you, though. What works for you may not work for somebody else. Got the x plus 1. Got the x. Okay, I don't need anything else. I'll just use a 1. Again, if you're more comfortable writing it like this, and then just noticing, hey, these are the exact same thing. 1 will do me good. That's fine. And I also notice that's going to be the exact same thing that happens on my last one. Check x. Check x plus 1. I just need the 1. But it all was made more simple because I factored first. If I wouldn't have, this would have been a mess up top. I'd have had a lot of work to do. So once our numerators are fully built, thank you again, Denominator, for helping me out. Don't need you anymore. And we just simplify our numerators. And it gets pretty easy pretty quick. Solving for x, we'll add the 5 over. And we'll divide by 4. And when you punch it in your calculator, if you get a decimal, just math enter it. Because we're going to stay fractional here. And again, don't forget to check to make sure it's not going to be extraneous. So 9 divided by 4 plus 1, not a problem. 9 divided by 4 times 9 divided by 4 plus 1, not a problem. We're good. So you can start to see, okay, this is kind of how these are going to work. But again, keep making sure those denominators, you're looking to make sure if you can factor them, you do. Because it does make your life easier. Last one I'm going to do, way down here at the bottom, we're going to hit the last one up. Now this one looks, when I first look, not as bad as it's going to seem. All right. Let's keep doing what we've been doing. I do not care about the numerator here at the start. All I care about is, can I factor my denominators first? So let's look at that. K minus 6. Okay, that's good. K to the third minus 10k squared plus 24k. Okay, I see a couple of things going on here. First, they all have a k. So let's get that out. We'll reduce the k's each by 1 on the inside of the parentheses. Then I look again, though, because I still see k squared. I might be able to factor that. That might be a diamond problem. I got to at least try. So my multiply number is positive, which means my signs are the same. They're either both positive or they're both negative. Bingo! How do we know? We look at the middle sign here. And as I had from an excellent help here, 6 and 4 multiplied to 24 get me to 10. So I actually had to kind of play the factoring game with that twice. So once I've done that, now I'm ready to build my LCD. So I start working my way down my checklist. Okay, coefficient, I don't have any numbers that are hanging out in front. Okay. Oh, dang. I did miss one. I didn't even think about my last term here. Here, again, I've got a K in common. Man, lucky we saw that. That would have been some extra work. So we'll get that factor. Now I can do the checklist. Coefficients, nope, no numbers in front. Single variable. Yes, there's a K hanging out here on its own. So that's part. Okay, and then each set of parentheses I see. So I see K minus 6. I see K minus 4. And then they repeat. I don't need them all. Okay, I've got the K minus 6. Don't have to write that anymore. So that's going to be my LCD. So, this one's a little bit chunky, but that'll happen occasionally. Okay, now again, no canceling until the end. Some of you may be pondering right now, maybe, hey, I could factor what's up there in the numerator. Should I do that right away? Good thought process, but no, because it might mess with our simplifying here in a minute. We might just have to undo it. So we're going to leave the numerators alone. But we are going to start working our comeback here on how this works. Now again, I, especially in this case, I'm probably just going to check off the things that I have. And anything that doesn't get checked off, which in this case would be the k and the k minus 4, I'm going to go ahead and get those in. When I get to my middle one here, I've got the k, I've got the k minus 6, I've got the k minus 4. I got it all. So I just need a 1. And then I do my last one here. I've got the k, I've got the k minus 6, but I do not have the k minus 4. That was a little bit of work. We got a little left here, but we got this. So now that we're done doing all of our numerator building, okay, never until then do we get rid of the denominator. But once we do, we get that done, and we start to simplify. K times k is k squared minus 4k. Remember here when you get to the middle, this is a negative 1. Maybe just put the negative on the 1. That might be an easy way to remember. And we're going to distribute that through. Make sure my equals doesn't get lost. And then over here, I might have a little side work I need to do. I need to box or FOIL this out. So if I need a little side room to work with, and I've always got either some scratch paper or graph paper or something in the front you could use if you needed some scratch. And I multiply my edges of my box together. And start looking for like terms. Negative 4k, positive 4k. Okay, that's out. So once we've done our multiplying, I look and I go, okay, normally we want to get all of our terms to the k squared side. So let's see. If I minus my k squared, I notice something. All the k squareds disappear. And I also notice I've got like terms. Now, negative 4 minus 4 does not cause 0. They're not opposites. Negative 4 and negative 4 would be negative 8k plus 12 equals negative 16. And now we're just going to solve like we normally would. Grab our calc here. Negative 28 divided by negative 8 is decimally, math enter, enter, 7 over 2. And you're like, do I really have to plug that in? I'll tell you something. Let me come back over here for a second. Okay, I noticed when I got up here it was 3.5. I think we can use some common sense here. Is 3.5 minus 6 going to get me 0? No. Is 3.5 minus 4 going to get me 0? No. So I can pretty much say I'm okay without having to plug it in for every single one. Okay? So that, ladies and gentlemen, is kind of our overview of this again. Is there some detailed stuff we got to watch for? Heck yeah. But again, it's going to help get you ready for some past stuff and also some things we're working on currently. Tomorrow we start in with some applications of this. Okay, and we'll be looking at a test a little bit later next week. But practice, 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 and check, check, check answers.